Good morning student, myself Milisakhla, and in today's session we solve the example of strain and energy. Okay, now we start with our example. Okay, first of all we read the given data and which unknown values. Here we find out that we find steel bar 100 centimeter long and rectangle section 40 mm by 80 mm subjected to axial load that is 1 kilonewton. Find maximum stresses by gradual loading applied suddenly and load is applied after falling through a 8 centimeter height. That means it is our impact loading. And also find out strain energies in each of the above cases and take E is equal to 200 gigapascal. Now one by one we first of all mention the data here. Our L is equal to 100 centimeter. That means 1 centimeter right here, 1 centimeter is equal to 10 mm. Okay, this is our solution of example. Now 100 into 10 is equal to 1000 mm. Okay, and Young's modulus E is equal to 200 gigapascal. 1 gigapascal is equal to 10 raised to 3, so 200 into 10 raised to 3 Newton per mm square. Okay, here we convert this unit into Newton mm. Next, here H is given 8 centimeter and this is equal to 80 mm. Okay, now area is equal to 40 into 80. 8 4 are 32. 32 3200 mm square. Okay, now first of all we find out stress and then we find out strain energy for different type of cases. First we write down here when. Okay, first we write down when load is applied gradually. When load is applied gradually. Okay, load is applied gradually. Now we discuss all the equation in theory portion. For load is applied gradually, our stress is equal to load divided by area. Now here value of this load is given P 1 kilonewton and convert this kilonewton into Newton. 1000 Newton. Clear? Now put the values here. 1000 divide by our area. We recently find out 3200 is equal to 0.3125 Newton per mm square. Okay, next we find out strain energy. What is the equation of strain energy? Strain energy for gradual loading U is equal to sigma square twice E into volume, where volume is equal to area into length. Okay, now we simply put the values here. Next, put the values U is equal to, first U is equal to sigma square then twice E into area into length. Now sigma we find out 0.3125 square and 2 into E is equal to 2 into 10 raised to 5 and area is equal to 3200 and our value of L is equal to 1000 and my answer of this U is equal to 0.781 Newton into mm. This is the unit of strain energy. Okay, Newton into mm. Okay, because load is in Newton and the distance is given in mm. Now second case. Okay, now we follow our second step. In second step we find out load is applied gradually. Okay, write down here when when load is applied suddenly. Sorry, first case gradual is complete. Now second, load is applied suddenly. Okay, load is applied suddenly. Now what is the equation of stress for that? Stress is equal to 2p by A. Now simply put the values here. 2 and values of P is equal to 1000 and here area is equal to 3200 and my answer is equal to 0.625 Newton per mm square. Now second, we find out strain energy. Right here, strain energy for this case, U is equal to sigma square then twice E into volume. Now volume is equal to area into length. So right here, sigma square then twice E into area into length. Now one by one put the values here. Sigma is equal to 0.625 square divided by 2 into 2 into 10 raised to 5. Area is given 3200 and length is given 1000. Okay, and my answer for this case is equal to 3.125 Newton mm. Okay, write down final answer. U is equal to 3.125 Newton mm. Okay, write down here. This is our strain energy due to sudden load. Okay, this is due to sudden load, and first is due to gradual load. Okay, due to gradual load. Now our third case left, that is our impact load. So write down here. First of all, make a heading. Now the load is applied. Third case, load is applied as an impact. Okay, when height is given, that is simply case of impact load. Remember that. Okay, now what is the equation of sigma? Sigma is equal to P by A plus under root of P square divided by A square plus 2E PH by AL. Now one by one we put the values in this equation. P is equal to 100 into 10 raised to 3 divided by area is equal to 3. Area is given here. Our P is equal to 1000 only. Okay, remember P is equal to 1000. Simply this is a mistake done by me. Correct this. P is given this example, that is 1000. Okay, right here P is equal to 1000 plus under root here P square, that means 1000 because our load is 1 kilonewton. 1000 square divided by 3200 square. Okay, plus 2 into 2E is equal to 2 into 10 raised to 5. Again P is equal to 1000 and H is equal to 80 centimeter and divide by area 3200 and our L is equal to 1000. And after solving this, my stress sigma is equal to 100.31 and unit of this stress is equal to Newton per mm square. Okay, now second we find out strain energy. So write here, strain energy U is equal to sigma square then twice E into volume. Now sigma square then twice E volume is equal to area into length. Now one by one we find the values that put in equation 100.31 square sigma square. Okay, then 2 into Young's modulus, 2 into 10 raised to 5, and area is equal to 3200 and L is equal to 1000. Now after simplification, U is equal to 80.5 Newton into mm. Okay, now my final answer U is equal to 80.5 Newton into mm. And this strain energy, write down here, this strain energy due to impact load. Okay, this strain energy due to impact load. Okay, this strain energy due to impact load. Here our example of strain energy is complete. In this example, we find out stresses for different load and also energy with respect to this different type of loading. Okay, now our second example is, now again before solving this example, read the given data properly. Okay, here steel bar 3 meter length and area is equal to 1000 mm square. In cross section suddenly, okay, here sudden word is given, that means given load is our sudden load. Axial pull of 20 kilonewton and find maximum stress, then maximum elongation and strain energy and also E. Now we solve this example, and before starting solving this we mention the data. Here L, first data is equal L is equal to 3 meter, that means 3 into 1000 is equal to 3000 mm. Okay, because we try, our unit is in Newton mm. Okay, now next, if kilonewton is given, then permanently we take meter, but if Newton is given, then convert into meter. Okay, second, our load is P 20 kilonewton, because value of Young's modulus is given in Newton mm, so we try to convert into Newton mm. 20 kilonewton, that is equal to 20 into 10 raised to 3 Newton. Second value is given area is equal to 1000 mm square, and value of this Young's modulus is given 2 into 10 raised to 5 Newton per mm square. Okay, this is the simply case of sudden load. So first of all, write down this load is a sudden load. Okay, this is the case of sudden load. Now we simply follow the equation of sudden load. First we find out stress, so right here stress, because area is given, so directly we use the equation. Stress is equal to 2P by A. Now 2 into P is given, value of P is given 20 into 10 raised to 3 divide by our area 1000, and my answer of this stress is equal to 40 Newton per mm square. This is my first answer. Now second, we find out elongation, so right here second heading elongation. Okay, and equation of this elongation is equal to sigma L by E. Okay, stress we find out, so put the value 40 into L, length of bar is equal to 3000 and Young's modulus is equal to 2 into 10 raised to 5, and my answer of this elongation is equal to 0.6 mm. Clear? Now third value we find out strain energy. So right here strain energy U is equal to sigma square, then twice E into volume. Okay, now sigma square second 2E into volume is equal to area into length. Okay, now one by one put the value. Sigma is equal to 40 square, then 2 into area, Young's modulus is equal to 2 into 10 raised to 5, area is given 1000 and length is given 3000, and my answer of this U is equal to 12,000 Newton mm. 12,000 Newton mm. Okay, here we find out our three values. This is our strain energy, then we find out delta L, and then we find out stress. Okay, and our example of the strain energy is complete here. Now in next session we solve another type of example. Just now we stop here. Okay.